Hello and welcome back. My name is Amir and this is project number 24 of the project-euler series. So let's go and see what we are facing for today. Right, a permutation is an ordered arrangement of objects. So for example, 3, 1, 2, 4 is one of the possible permutations of the digits 1, 2, 3, and 4. Okay? And if all the permutations are listed numerically or alphabetically, we call it lexicographic order. So the lexicographic permutations of 0, 1, 2 are 0, 1, 2, 0, 2, 1, 1, 0, 2, 1, 2, 0, 2, 0, 1, 2, 1, 0. Right, so if you check from left to right, it's getting bigger and bigger and bigger. What is the millionth lexicographic permutations of these digits? So these digits will be written as 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. The next one will be 9, 8. Then it will be 8, 7, 9. Then 8, 9, 7, and so forth and so on. You get the idea. So this is getting bigger and bigger as we go along. Right, so we need to find the millionth lexicographic. So in other words, we need to go 999,999 permutations ahead and find this one. So let me tell you how I'm gonna solve this problem. So let's suppose that our numbers are 1, 2, 3, and 4, like this. Let's make it a little bit bigger. So these are my numbers 1, 2, 3, and 4, and I want to see which one is the 15th. So as I'm going along, I will use 1 like 6 times. So if I put 1 aside from this list, the numbers that I can make with these 3 is 6. 3 times 2 times 1. So with 1 I get 6. Then I get to 2 and 1, 3, 4 that I am using, so it will be 6. So 6 numbers starting with 2. Then I would get to 3 that as a starting, and I will have 1, 2, and 4 as the rest of the numbers that I can use, and I will have also 6 numbers that start with 3. So it will be 12, and somewhere starting with 3 will be my 15th. As I'm getting to here, to 3, I will have 3 remaining digits. My remaining digits will be 1, 2, and 4. And I need to start using 1, then 2, and then 4 until I get to 15. So, in other words, I will count the number of factorials that can be used to get to this number, but beneath that. So at first I will remove 1. I see that I have 3 more remaining numbers. I will see how many 3 factorials are in 15, and I will add 1 to it, and that will be my first number. So how many 3 factorials are in 15? 3 factorial is 6, and 15 divided by 6 is 2 and something. So there are 2 full factorials in 15. So 1 and 2 are all used up. I will start with 3. So my number will be starting with 3. And I have used 12 numbers by these two. So the remaining numbers that I'm going to check is this. So I have reduced my problem to find the third digit that I can make with these 3 numbers. Again, I will leave one of the numbers aside. I would say I think that I have 2 numbers, and 2 factorial is 2. So how many 2's are in 3? There are 1. So 1 is used up. I get to 2, and my second number will be 2. So it will be 3, then 2, and I will remove 2 from my list. So it will be 1, 4. I have used 2 numbers, so there will be 1 remaining number. So my problem is reduced to find the first number that I can make with 1, 4, which is basically 1, 4. So I would use 1 here, and I will be reduced to 4, and there is no more digits remaining. So I will add 4 to the list. So this will be my like 15th number, providing these numbers. So to make sure this is correct, let's write it. So my numbers will be 1, 2, 3, 4, then 1, 2, 3, 4, 1, 2, 4, 3, 1, 3, 2, 4, 1, 3, 4, 2, and 2, 1, 3, 4, 2, 1, sorry, 1, 4, 2, 3, 1, 4, 3, 2. The same goes for 2. So it will be 2, 1, 3, 4, just replacing the place of 2 here. So 2, 1, 3, 4, then 2, 1, 4, 3. And so forth and so on. And if we count, we will see that this is number 15 as we expected. So yeah, it might be a little bit confusing in the first glance, but I urge you to check and see that this is the way that is working. So let me write the code. It might get much more clear as we write the code. I would say that my numbers are from 0 to 9. So, and the target number that I'm going to get to it is 999 and 999, so 6 nines. And this is my result. So it will be an array as I'm adding to it, and then I will join them all together, so it will be a number. So while there are items in my list, I want to go on. So then I need to have a function that based on my items and how many is remaining to get to the target gives me the index of the number that I am going to take out and the remainder. So as I had there, so it was 1, 2, 3, 4, and I gave it 15. It gave me back 2 trees. One was that the index of the number, which is 2, but the number itself is 3. So it would give me back 2 as the index that I'm going to remove from the list, which is this one, and 15 minus 12, which is 3. So that I can use for my next iteration. So I am sending these two values and I'm getting these two back. So let's say and I need to write this function. So but before that, let me write my idea. So again, I'm sending these two values to this function and I'm getting the index and the remainder, I will push to my result the item that is at that index that I am getting, and I would say that my next target that I'm going to check is the remainder that I get from that value, and then I will cut out that number from the list as done here. So if it's 2, then I would say that okay, items is these ones plus these ones. Right, and I will basically log the result, of course, which is the result that is being joined by the nothing. So yeah, I need to just write this function. Right, so I am getting the factorial of the remaining items. So if I have 10 numbers here, then I would get the factorial of 9, and then I would see that how many 9 factorials are existing in the target. And then I would do this calculation and send back these two values that are being used here. So I need to write this function as well, which calculates the factorial. This will be fairly simple. Right, I am doing the factorial here as well. So this should be it about this puzzle. Let me run it. Not this, but this. Yeah, I'm getting a great number starting with 2. So yeah, I will urge you to go and check the logic that has been used here and see if you can get up with a better idea. So yeah, thank you for watching again, and see you in the next puzzle then.